There's three parts to graphing a system of linear inequalities. For each line, we need to find the line, determine if it's going to be a solid line or dotted line, and then figure out which side to shade on. So for the first line, y is less than or equal to x plus 2. That line has a y-intercept of 2 and a slope of 1. So we need to go up 1 over 1. And just to make things nice and neat, I'm going to continue that slope all the way across my graph. Now determine if the line should be a solid line or a dotted line. That comes in right here with the inequality. Because this inequality is less than or equal to, that means that our graph is going to have a solid line. And the last step is to determine which side of the line we should shade on. Well, since this inequality says y is less than, y is talking about the up and down direction, and the less than means down, because down is less than up. So once again, look right there. That trick works only if it says y is less than or y is greater than. So anyway, y is less than the line. We're going to have to shade on this side. For the second line, y is greater than or equal to negative x plus 2. Again, that has a y-intercept of 2 and now a slope of negative 1. So I'm going to go down 1 over 1 and continue that slope all the way across my graph. Again, this inequality is greater than or equal to, so we'll use a solid line. And we need to decide which side to shade on. Since it says that y is greater than negative x plus 2, up is greater than down. So we're going to shade on this side of this line. Now where's our overall solution? It's going to be where these two regions overlap. So it'll be just this part of the graph. For the next example, again we have two lines, but this first line is written in standard form. So we need to think about x and y intercepts. If we let x equal 0, we'll have 2 times 0 minus 3y equals 6. Negative 3y equals 6 means that y is equal to negative 2. If we let y equal 0, we'll have 2x minus 3 times 0 is equal to 6. And 2x equals 6 means x is equal to 3. So we can plot these 2 points, 0, negative 2, and 3, 0, and that'll be our line. Again, we should kind of continue this slope up 2 over 3 all the way across our graph. Now, look at the inequality. Since this inequality is strictly less than, not equal to, it means our line should be a dotted line. Then we have to decide where are we going to shade. So we can't use that trick of you going up and down based on the inequality because it doesn't say y is less than or equal to. Instead, it says this whole equation is less than or equal to. So we have to test a point. I'm going to test this point that's not on the line, 0, 0. And I'll just plug it in. Is 2 times 0 minus 3 times 0 less than 6? Well, is 0 less than 6? Yes. So that means this is the side that we're going to shade on. For our second line, that's in slope-intercept form, so we can just grab the y-intercept of negative 3 and a slope of up 3 over 2 and continue that slope all the way across our graph. Again, this inequality is strictly greater than, so we're going to use a dotted line again. And we have to determine which way we're going to shade. For this inequality, it does say y is greater than. So since y is talking about up or down, up is greater than down, which means I'm going to shade on above this line. Our solution is going to be the overlap, which ends up being this region right here. Kind of a mess, but you can still see the boundaries are above both lines. For the last one, we have two ugly equations. The first one is a line. It's written in point-slope form. The point coming from the x-coordinate is going to be -1, and from the y-coordinate it will be +1. So I'll plot that point, and then use my slope of -1/3 to continue that slope all the way across my graph. So I'll go down 1 over 3, working backwards, up 1 and back 3. This inequality is less than or equal to. Since it's or equal to, we're going to end up with a solid line. And we need to determine which way we're going to shade. So I'm going to pick a point, again like 0, 0, and just plug it in. Is 0 minus 1 greater than or equal to -1/3 times 0 plus 1? Well, if we simplify that, we'll get -1 is greater than or equal to -1/3. Is that true? No, it's not. That means we're going to have to shade on this side of the line. In my second inequality, that's an absolute value inequality, so we got to be careful with that. The vertex from the x-coordinate is going to be -1, and from the y-coordinate is going to be -3. So -1, -3 is our vertex. Our slope will be 1, so we'll go up 1 over 1 all the way across, and up 1, back 1 all the way across to get that distinctive V. When we draw this V, it should be a dotted line. And because this inequality says y is greater than, up is greater than down, and we're going to have to shade above the inequality. So where's our solution? It's going to be above the V and above the line, which means it'll be this region right here. And that's how you graph inequalities.